All right, hello Algebra 2, Mr. Walker back with you. We are doing the Chapter 9 review. Here's what you can expect. Video 1 is going to be page 1, video 2 is going to be page 2. So we are going to go ahead and just jump right in with the first four. We want to find the first four terms in each sequence. Number 1 and number 2 are going to be set up the same way. Number 3 and number 4 are going to be set up the same way. So if I want to find the first four terms in the sequence here, that means I need to find A1, A2, A3, and A4. And finding these is actually pretty simple. All you gotta do is plug in 1, 2, 3, and 4, respectively, into the sequence rule that they give you. So for instance, I want to take negative 20 plus 7 times 1. And then down here, I want to take negative 20 plus 7 times 2. I say 2 and I write 3. Dagnabbit. Let's try that again. There's a 2. Negative 20 plus 7 times 3. And then negative 20 plus 7 times 4. And that's all you got to do. You just got to evaluate from there. Whenever you do that, you get the following numbers. Negative 13, negative 6, 1, and 8. Crank them out yourself if you don't believe me. But those are the first four terms in the sequence, respectively. Negative 13, negative 6, 1, and 8. In that order. Number 2, set up the exact same way. I want to find A1, A2, A3, and A4. There we go. And again, we're just plugging in 1, 2, 3, and 4 into the sequence rule that they give us. So in each case, it's 0.75 times negative 4. First is the 1 minus 1 power, which is simply 0.75. Why is it 0.75? 1 minus 1 is 0. Negative 4 to the 0th power is 1. 1 times 0.75 is 0.75. Plug it into your calculator if you don't believe me. So negative 0.75, or not negative 0.75, positive 0.75 times negative 4. I was getting my negative mixed up. This time it's to the 2 minus 1 power. Whenever you plug that in, you get negative 3. 2 minus 1 is 1. Negative 4 to the first is negative 4. Negative 4 times 0.75 is negative 3. 0.75 times negative 4, this time to the 3 minus 1 power. Here we get 12. And then finally 0.75 times negative 4 to the 4 minus 1 power. And you should get negative 48. So in that order, 0.75, negative 3, 12, and 48, those are the first four terms of the sequence. All right, excuse me, number 3 and number 4, here we go. Once again, finding the first four terms, they already give us A1 for each of them, 3.9. So that leaves us with only 3 other things to find, A2, A3, and A4. How we find them is a little bit different than what we did up above. For these ones, we have to take each respective term before and then subtract 0.9. Because right here I say AN equals AN minus 1. That indicates the term before, remember, plus 0.9. So if I want to find A2, for instance, I need to take whatever A1 was and subtract 0.9 from it, which is, in this case, 3.9 minus 0.9, which is simply 3. A3, we have to take A2 minus 0.9, which is 3 minus 0.9, which is 2.1. And A4, we simply take A3 minus 0.9. Once again, for each respective term, we're taking the term immediately before it and subtracting 0.9. So here I get 1.2. So here are my next 3 terms. Here's my first term. So A1, 3.9, then comes 3, then comes 2.1, then comes 1.2. Number 4, set up pretty much the exact same way. We're finding A2, A3, and A4 with each time we're taking the term immediately before it, and this time we're adding 7. So they give us A1, which is negative 15. That's good to know. So we have A1 plus 7 this time, which is negative 15 plus 7 equals negative 8. If I want to find A sub 3, I take A, that's supposed to be an A. Don't know what in the world I'm doing there. Come on, give me the eraser. There we go. Okay, so we take A2 plus 7. A2 is negative 8, so I take negative 8 this time, plus 7 is negative 1. If I want to find A sub 4, here we go. I take A sub 3 plus 7. A sub 3 is negative 1, so I take negative 1 plus 7, and I get negative 6. So those are A2, A3, and A4 respectively. Here's A1. Number 5, 6, 7, 8. We want to find the recursive formula for each one. So let's look at number 5, shall we? I noticed to get from 28 to 8, I have to subtract by 20. So maybe I'll write it down here. So I subtract 20. To get from 8 to negative 12, I again subtract 20. From negative 12 to negative 32, once again, you subtract 20. Now, how does that help us? Well, for starters, I can find a recursive formula. So with each one, to get from one term to the next, I take the term before it, and I subtract 20. So an minus 1 minus 20. And here, let's identify the first term as well. First term is the very first one on the list. It's 28. And that's it for number 5. Number 6, let's go ahead and just identify the first term, A1. That's negative 37. Cool. Now we got to figure out the formula rule. Hopefully this one's pretty easy to spot. Here, I'm just adding 10 from each term to the next. So to find the nth term, I take the term before and I add 10. And that's the recursive formula rule for number 5 and number 6. Number 7 and number 8 are just a little bit different. Because here we're going to actually look for stuff to multiply. Excuse me while I get a drink quick. Excuse me. Okay. Like I said, I want to see if I can find some stuff that I can multiply over and over again. So let's take a look at number 7. Now I noticed I alternate between positive and negative. So that means I'm going to be multiplying by a negative number specifically. Now to get from 25%, 0.25 to 1, I have to multiply by negative 4. From 1 to negative 4, yeah, that checks out. Multiply by negative 4. From negative 4 to positive 16, once again, multiply by negative 4. Okay, cool. How does that help us? It helps us like this. A sub n equals, I'm going to take the term before and minus 1, there we go, and I'm multiplying by negative 4. And the first term, a sub 1, is negative 0.25. There we go. So that's number 7 done. Number 8, all of my terms stay negative. So that tells me I'm going to be multiplying by a positive number instead. So 3 times what is 12? Or negative 3 times what is negative 12? Same question, it's 4, 4, and 4. So we're multiplying by 4. So if I want to find the recursive formula, I take the term before, this time I'm multiplying by positive 4. And if I want to identify the first term, it's simply negative 3. Now, you may have guessed, if you notice between number 9 and number 10, I put a red slash through them. We're skipping those 2. So we are going to jump right into number 11 and number 12. And then from there, number 13, number 14, and that'll conclude the first video. So I want to find the explicit formula. Now, number 11 and number 12, they are both geometric, which means I have a common ratio, the same number that I'm multiplying to get from one term to the next. I alternate in number 11 between positive and negative, so I'm going to be multiplying by a negative number. So here, I'm actually multiplying by negative 2. To get from negative 6 to positive 12, multiply by negative 2. Positive 12, negative 24, once again, multiply by negative 2. Maybe if I could correctly draw a 2. There we go. Okay. So let's identify the first term. It's 3. My common ratio, we call it R. That's negative 2. Now, for a geometric, sequence, excuse me, if I want to find the explicit formula for it, I take an, set it equal to the first term, a1, times r to the n minus 1. We know a1, we know r, so we're in good places. So an equals 3 times. Now, if you were asked to evaluate this, and you will be later, make sure you put any negative number in a set of parentheses. It's just going to make life a whole lot easier, and it's going to make your calculator less confused. So there we go. There's number 11. Number 12, same type of deal. Now, all of my terms are positive, so I'm multiplying by a positive number. And in fact, I'm multiplying by 6. So identify your first term. That's 4. Your ratio is 6. We're in good places. We know what we're doing. An equals, once again, first term times your common ratio to the n minus first power. So we take 4 times 6 to the n minus 1 power. If you want to put that 6 in a set of parentheses as well, you certainly can, although it's not necessary. There we go. Number 13, number 14, last two for page 1, and then I'll conclude the end of this video. So for number 13, 14, we want to state if it's arithmetic, geometric, or neither. If it's arithmetic, then we're adding or subtracting the same number. If it's geometric, we're multiplying by the same number. Now let's just check if number 13 is arithmetic first. 96 to 48, I have to subtract 48. If I subtract 48 from 48, I get 0. But here I see a 24. So it's not arithmetic. Let's see if it's geometric, if I can multiply by the same number. 96 times a half is 48. 48 times 1/2 is 24. Okay, we're looking good. 24 times 1/2, that does get us 12. And 12 times a half, that does get us 6. So yeah, multiplying by the same number, 1/2 over and over again. So this one is actually geometric. Number 14, let's check if it's arithmetic first, or arithmetic, depending on how you pronounce it. Anyway, to get from 22 to 2, I subtract 20. Let's just check if I can subtract 20 over and over again. 2 minus 20, that does get me negative 18. Negative 18 minus 20, that is negative 38. Negative 38 minus another 20, that is negative 58. So this one, we're subtracting by the same number over and over again. This is arithmetic. And that's the end of video number 1. So if you've got questions, let one of the algebra teachers know. We're more than happy to help you. Otherwise, stay tuned for the second video. We'll see you soon.